Welcome everybody to the fourth episode of Dr. Data Science with myself as host. My name is Noor Hosseini. I'm based in London. I'm a lead data scientist with TIBCO. And today we actually have a fully in-house team, so it's all TIBCO people. We have Vaibhav Kidigiri. Vaibhav, you want to tell us a little bit about yourself quickly?
Absolutely. Thank you so much, Nora. Hi, my name is Vaibhav, and I'm also a lead data scientist for the TIBCO Data Science team. Yeah, excited to be here for the Dr. Data Science episode, where we'll talk a little bit about and low-code ML environments.
Yeah, and we also have Sweta here with us. Sweta, would you like to introduce yourself as well?
Sure. So, hi everyone. I'm a data scientist here and I'm located in New York. Very excited again to be on a Dr. Data Science session.
Thank you both for joining again. I know you've been guests in the past, so it's really flattering that you're returning. Today, Vaibhav and Sweta are going to walk us through basically low code machine learning environments, and the other way to say this is possibly like data science platforms. What do they look like? And they're going to talk us through one example from TIBCO's own no low code machine learning environment called Team Studio. But before we dive into the demo, I wanted to talk a little bit about what this whole space is. So there is this, cliche of how computers are depicted within Hollywood and series and whatever as just zeros and ones. But essentially, this is the language that our machines learn and understand. Everything within this computer, all the different cameras and audio and microphone, everything that's working within this computer now boils down to the zero and one code. But we don't always want to have to drill down to such a low level, right? It's always a little bit difficult to think about everything that you'd have to know on a very, very granular level. Like, for example, maybe you don't know how your car works, but you know how to drive it. So there's abstractions and sort of layers on top of layers. And this is what we're going to talk about today, how the no low code environments are the new level of machine learning and where it's going. So how low can we go? Coding is actually a lot of layers of abstraction built upon each other. The machine level code is the 0-1 language sort of fuzziness that you saw previously in the picture. And essentially what it's doing is it's telling your CPU what to do, right? How to make things work. Beyond that, there's also this so I'm going to just go through the hierarchy of the different layers of languages and that we use to be able to make machines work the way that we want them to. So you also have bytecode, which is a level above machine code, but it is a level below compiled language. So for example, if you've ever worked with things like with languages like C++ and Java, these are languages that actually have to be used. You have to use a compiler so that you can change whatever you've programmed into something that is machine level code for your language to actually translate into a file that will execute in your computer. What a lot of data scientists are using nowadays is interpreted language. So that's stuff like Python, which is the reason for it, I'll explain in a second, it has mostly to do with the libraries. But essentially, an interpreted language doesn't need even a compiler. It does and abstracts all of that stuff for you as well. So essentially, all of the different instructions that you're writing when you're writing like a Python script, the computer takes care of that, takes care of translating that into machine level code. You don't even need to worry about your compiler coming back and saying, oh, this didn't compile for whatever reason. And then on top of that, we have things like libraries, which are essentially just snippets of code that you can then pull up. So in Python, it's quite popular to have data science libraries like scikit-learn and pandas or whatever that have different methods that you can use to be able to execute things quickly. So you'll be able to tell, your data frame that you want to do some kind of filtering process or you want to try out a random forest algorithm. You can do that without having to actually write the algorithm of a random forest each and every time. And so essentially, this is just the natural evolution of civilization, I think, as well, in that you're always going to be building on top of things to make things easier and easier as you go along. I actually really like this example. So all of these definitions are taken from Wikipedia, and I liked how they show you that there's, maybe you don't see it very well here, but there's types of code. You've got source code. So source code is things that I'm talking about, like Python and Java, and then it can go all the way down to machine level code and microcode. So this is essentially what we're talking about when we talk about AI platforms, in that we are abstracting away even the languages sometimes. In the Team Studio case, that's Scala, but in other situations, in other platforms, it might be something different, right? And this space is actually really moving. This is a graph from CB Insights about the last Q3 to 21, all the different M&A deals, and you can just see that it's just expanding tremendously. And I actually think that we haven't even seen where this will go. A lot of enterprises are still at a sort of lower level of maturity that has yet to be capitalized on. And when these startups and these other, initiatives take off, we'll actually see a lot of movement within the scene as well. Um, for example, we know Databricks has recently acquired 80 Labs, which is it's kind of like a low no code environment, similar to the one we're going to show you as well. And Databricks being one of our competitors, shall we say, recently making this acquisition bodes towards this thinking, right? That moving towards abstracting away even just coding languages for data scientists. And then recently, Cascade Labs, one of the newer players on the scene, it has raised 5 million for a no-code data automation platform. And this DAG and this visualization that you see here in the bottom will actually look really familiar after we walk you through our Team Studio environment. So, Vaibhav, over to you.
Great. So thanks, Nora. Let's get into this a little deeper. And what we see on the screen here is just the landing page of the TIBCO Data Science platform, Team Studio, where we're going to talk about how users or multiple personas can access machine learning. So I'm going to go right into this because the fun stuff is when you start looking at stuff. So this is the landing page, and once you log in, you see a little snapshot of things like a very high level snapshot of how many workspaces you have, how many data sets have been associated with those workspaces, and the work files, and the number of people who are there right now. And again, I'm going to get into the concept of workspaces and work files in a bit. Scrolling down, you can also just see a more visual representation of the activity, and you can just slice and dice that in many different ways. So hovering over to the top left, if you click on the hamburger icon here, we see a few options here. And I'd like to first start off by getting into the people aspects. And since TIBCO Data Science is a super collaborative platform, there is a very good access control, meaning that TIBCO Data Science provides a set of user personas that you could select from, and each of them have different access control. For example, if I'd like to add someone, as you can see here, under the application role, you could have someone going all the way from an analytics developer to just a business user. And the difference really between these roles are the access to what we call as operators, which we'll go in a second. I do want to go on and let's hit to the data sources tab. And here we see basically on this hosted, so this is our hosted instance, it really shows us all the data sources that have been configured within this hosted instance from now. So we do have a list of what we call them as non-analytic data sources. And also analytic data sources, like you see here, the Hadoop enabled ones. There are definitely a list of data sources, both Hadoop and non-Hadoop, that we support, which is available through our documentation. Now I'm going to go over to the most important aspect of this platform, which is the concept of workspaces. So what is a workspace? So you can imagine workspace as this little playground where you can have multiple multiple people with multiple different user personas in a team working on a single project where everyone, all the users can access the assets. So I'm going to take an example here. And let's say I've been working on something called life expectancy. So I'm going to go to the search, hit enter. As you can see, um, when I want to search for anything, the results that I get are going to be categorized into multiple things. So things like work files, things like data sets that are associated with my search term. And what I'm interested in mostly is actually the workspaces. So I'm going to go into the workspace of my choice, which is here. Now, once we get into the workspace, and this is where the super collaborative nature of TIBCO Data Science shows up, right? So we have our overview tab, which kind of tells us the activity on this workspace by itself. So, it can tell if you've made any changes, if you've added any files, or if you have added any analysis. It could also highlight things like any insights or notes that you've made. Looking to the right, you can also see the workspace membership. As you can see, I'm the owner of this, but I also have a few of my team members who have been contributing or collaborating on this project with me. My colleague Sweta here has been working on this project with me. There are a lot of options. There are options where you can change the workspace name. You can add or remove people within this workspace, and just to make it a little bit more customizable. One of the nice features about Team Studio is just the ability that you can approach data science and machine learning also from more of a project management standpoint. So going over to the milestones, this is where project management. From a project manager standpoint, they can set up these little milestones, which kind of tell you how far you are into this project, or if there are any blockers or not. So in this case, we have basically three main milestones: data prep, modeling, model deployment. You can see all of these are completed, but you can actually see the progress of your project within the overview tab. I am going to go on to where we do meat of the work, which is work files. So work files are contained within workspaces. So here within work files, there's several things that we could do. If you hover over, or if you look towards your right, you can see that I can create a new SQL file. I can also create a new Jupyter or Python notebook, and I can also create a new workflow. Now, this is where we're going to get into the low or no code aspect of Team Studio. For the sake of this example, I do want to walk you all over a sample workflow that we've been working on. So I'm going to hover over to this window here. And what you see here is when you click on any workflow, and this is what a canvas looks like. So there are a few things to keep in mind here. So on the left part of the screen, so there is the data, right? Now your data can be sitting in multiple different sources. In this case, we have our data sitting in a Cloudera instance. Getting the data from your source is as easy as just going into it and just dropping the data onto your canvas, right? Team Studio has, or TIBCO Data Science Team Studio has this really neat feature where it tells the user, it's very intuitive. It tells the user if what you're doing is right or not. So if you see something like this, it means that, well, this shows up as red. This means that this needs to be configured further. So double clicking on this, I can see a little panel that opens up, and anything that needs to be configured shows up or shows itself up as like highlighted in yellow. So in this case, I go in here and I just give a cursory look at what my data looks like, things like data types or even renaming of the columns. I can do that all here. Go ahead, press OK again here. And now you can see that, this operator is now configured and we're ready to run this. And this is just the same principle that extends to all the other operators within Team Studio. I'm going to go ahead and delete that, and I'm going to go over this example. So here, basically, we have some data around health and economic indicators. Now, this data has, as you can see here in the results pane, has 61 columns. We have some country, we have some other indicators relating to, female and male and things like, electricity and life expectancy. And what we really want to do here is, in this analysis, we really want to predict the life expectancy. Now, this is a very large problem. So how do we go about doing this? And this is where Team Studio provides this plethora of operators that are available to users. Now, clicking on this, you could see that there are operators that range from loading of the data to transformation to even modeling, prediction. We have operators which are very specific to NLP, where my colleague Sweta is going to go over that in a second. And it's as easy as just dragging and dropping to make a very logical connection. It's just like how you would think your data science life cycle would be, right? If I get my data, I want to perform some sort of an exploratory analysis, things like looking at, specific columns, or things like, doing some sort of a null value replacement, trying to understand the correlation with the dependent variable. We normalize our data here. We split our data into training and testing. And here is where I think TIBCO Data Science is super powerful. I can train multiple models on the fly, right? And we're not just limited to these. Here you can see I've taken an example of training this model through linear, gradient boosting, random forest, and even this is where I think this is super interesting. If you have different user personas, uh, data scientists who love to code, there is a place for everybody here, right? And they can you could have a one-off analysis that's written in Python, but you also want to kind of incorporate that within your larger workflow. You can do that. As you can see that we've done exactly the same thing here. Um, Getting into this a little deeper, there are multiple ways. If you want to go about deploying these models, we can deploy them in real time or in batch. You could deploy them within TIBCO Data Science or even outside of TIBCO Data Science. There are some operators which allow you to visualize, as you can see here. I'm able to visualize my results. This is just a simple example of where I'm taking in all the predictions from all our model and trying to just compare that with the actual value that we have here, which is a life expectancy. So I am going to go into some other aspects of building a workflow. As you can see here, once you have the results that you need, there's several ways, right? You can write the results back to the data source itself, which is what I'm doing here. You can also export this into a Spotfire binary data format. And if there are users who are very familiar with Spotfire, TIBCO Data Science has a very cool way to interact and talk with Spotfire. So you could just export the data set that you want from here, and you can import that into Spotfire to further analyze or visualize your data. In a similar way, I do want to touch upon some other things, which is around versioning. So how do we do versioning if you have multiple users who can open this workflow or collaborate? Team Studio provides or has its own internal versioning system. So by going into actions and clicking on the flow history, you can see all the different versions of this workflow. You can download any one of them, or you can also roll back and replace it to the current one. So this is just an example of how we can do some basic or even more advanced machine learning and data science within Team Studio. I am now going to go over back to our workspace within our work files. And now that we have trained our model, something that I would really want to do would be really to test my model with the incoming data or the new data that comes in. I'm not really going to open this, but we can quickly go over this. So the data here we see, this is the new data that's coming in. It would go through the same series of data transformations. Here, I have an option to load the model. As I said, you can select, you can select the best candidate model, and you can load the model, and you can predict, basically, or score it against your new data. You also have the choice to look at or add certain flow controls within your workflow, which allows the user to tell that if certain diagnostics of the model are, above or below a certain threshold, it will notify the users. Now, staying on the notification bit, I think the one other cool feature about TIBCO Data Science is the concept of jobs. So jobs is a very powerful automation tool within the platform. Users have the ability to run specific work files at specific intervals and also notify users on success or failure. So let's say that these are the three things that I wanted to run, right? I want to run the Python model that we built, the modeling workflow, and also our testing workflow. So let's go ahead and maybe edit, edit a job. Cool. So setting up job is very, very straightforward. As you can see here, you can schedule this on demand or on a schedule. Or you can also, once you have that, you can also kind of customize the notifications of the job itself. So if the job ran, if it's successful, who do I notify? If it fails, who do I notify? So the platform does allow you to customize at a very granular level indeed. Moving on to the concept of engines. Now, engines is just a very powerful way to deploy assets, and also a great way to just test, how your model is performing. I usually call engines as another like a service that's very similar to Postman. So let's say that I am interested, or I like the linear model, right? And I would like to just see how, or I would just like to see how this model is doing if I were to just pass one row of the data to the model. Am I getting the expected results? And that's where engines play a very important part. So I am now going to move over to the interconnectivity with Spotfire. So let's say that we have, we have our training that is done in TIBCO Team Studio, Data Science Team Studio. So how do we communicate with Spotfire? Or what if I want to invoke this training job from a dashboard? Now, how do we do that? So moving over. So this is a little Spotfire dashboard that we've built here, which kind of gives us a little bit deeper information than what we saw from TIBCO Data Science. So on the left part of the screen, you can see the prediction results by all the four models that we've built, right? This is AdaBoost, random forest, gradient boosting, and linear regression. And moving over to the right, the right-hand part of the screen, you can actually now start inspecting the model itself. We can look at the variable importance at a specific or at a selected country level, and you can also look at it at a worldwide level. So this is pretty cool because, maybe there are certain factors that are very specific at a country level, might not be very important at a worldwide level. So it'll be good to look at that sort of a correlation. You can see here, for example, in case of Australia, when you're predicting life expectancy, so the pump price for diesel is a very important factor. But if you look at it on a very global level, it's not super important. So these are just some of the ways you can slice and dice your data within Spotfire. The way to invoke a workflow from Spotfire is as simple as just, if you were to just drag and drop, let's say I'm interested in getting the predictions for France, right? I just select that and I hit the get predictions. Now, what this does here is that this starts, the data function allows you to invoke the workflow from TIBCO Data Science. So if I were to go back here and go to our administration panel, if I were to refresh, you could just see that we just kicked off this workflow from a Spotfire dashboard. And I think that is really, really cool. Well, I'm not going to go over trying to run this workflow because it can take a little while, but yeah, I do want to now give an opportunity for my colleague Sweta to take over from here and talk a little bit about NLP and what you could do with text within TIBCO Data Science.
So over here, this is just another workspace like the one that Viva brought before. This is called NLP, Ngram Features and Tagging. And I'm going to go ahead and jump right into this workflow called Ngram Features and Entity Tagging, and I marked it as low code itself. And the reason that we want to talk about a separate use case, specifically we're focusing on NLP or natural language processing. So data science itself is a very comprehensive branch, and one of the components that falls under this umbrella in a specific area is again natural language processing or NLP. And Team Studio has a variety of NLP specific operators. So if I go to this left-hand panel right here and I look at all the operators, we can see a specific category for those in NLP in general. And for anyone familiar with NLP, these are actually some of the most commonly used, as well as I think baselines for both modeling as well as data exploration. And when we look at this workflow over here, the reason we want to emphasize this is that there's a lot of inbuilt Team Studio operators in play, but we also have a couple of low code operators in these Python notebooks here, which we can look into too. So to start off, let's just look at this actual workflow itself. So we're looking at a hotel reviews data set. So you can imagine if you're staying at an Airbnb or a hotel, you might have some type of comment to leave. And this is going to be some type of text comment if we look at this reviews text column right here. And in order to just preliminary just get a better understanding of our data, we can pull other operation statistics, other statistics on top of this, whether it's like sampling some subset of our data or just being able to look at the different data types in this data set. And then we actually jump into some of the NLP work that we want to do. And here I've used inbuilt Team Studio NLP operators to both clean the text data. So here you can see a column called text clean that has the cleaned review. In this operator, actually, we do things such as remove special characters and actually even remove numbers if we want to. And then I can actually go ahead and bring that up so you can see how this is defined. So here, for example, we're actually just taking review ID and replacing it with both its special characters and any alphanumerics. And once we've cleaned the text, the next thing that we do is actually go ahead and build in this Ngram dictionary builder and text featureizer. So Ngrams are these contiguous sequence of words in any piece of text. So for example, if we look at this first review over here, an Ngram could be, a unigram could be just pleasant, a bigram, which are going to be two contiguous sequence of words, it's going to be pleasant min, and then likewise trigram would be pleasant min walk. So this is what we're actually extracting in this dictionary builder. And it's quite important because this gives us some types of features from the text. So we're effectively creating features from just this raw unstructured text data. And on top of that, we create what we call a text featureizer, which creates this Ngram matrix. So this might actually take a second to load because this matrix is quite huge. We see all the Ngrams, and the Ngram dictionary builder actually had a mapping to which ones are which. So this matrix that we see here can be used effectively in modeling. So over here, we actually have k-means running on top of this. I won't go too much into this, but effectively you could use that matrix to do further modeling. But what we did actually is we took this matrix and we ran the clean text as well as that Ngram matrix through some custom Python notebooks. So over here, I have a notebook for a sentiment analysis. So you can see that on top of this clean text data, I've effectively ran my own sentiment analysis using NLP libraries that I wanted to bring in, as well as done some work on keyword extraction that actually uses the TF-IDF scores from this Ngram matrix. But without going too much into the actual NLP that's being done, the interesting thing that we wanted to actually look at is just to see how we can take in those inputs from previous nodes and be able to actually use them to do further work. So here I'm effectively reading that text featurizer input, and then I'm taking the clean text from it. So all I need is a clean text. I'm not actually using the n-gram matrix here. And then I'm running it through my own custom code using the Spacey library from Python in order to call actually a few different things, both sentiment analysis as well as named entity recognition and part of speech tagging. And I am saving that end results and also being able to export it in that node that we just saw. And likewise, so that was an example where I was just working with the raw text itself from these previous nodes. But this keywords actually operation is going to be working with that n-gram matrix that we saw itself. So it's extracting keywords from that direct matrix input. So again, if I just scroll through this again, you could see that we're effectively taking all this data over here that we stored in Team Studio and just be able to get the top keywords based on both the text featurizer as well as that n-gram dictionary builder. And the reason that this is interesting for a few different reasons. It's both because we're able to use Team Studio inbuilt operators in order to do some pretty advanced NLP work, but moreover, actually build on top of those operators to do our own custom work. So it's a perfect example of how you can work in a specialized area with what we call low code operators, working on top of no code operators, essentially. And if I actually close out of this workspace real quickly, I'll show you before what I had initially, which was here what I've labeled a workflow called n-gram features and entity tagging high code. And the reason I call this high code is because it was doing all that work just in Python notebooks. And this is actually a way that a lot of engineers or data scientists might work themselves. Data scientists are quite familiar with just having endless streams of a single notebook or a variety of versions of the same notebook. And the problem with this is even if it might get the same job done, let's actually just look at these results for a second. So you can see that I actually have some of the same results from before. The problem is it's very hard for a non-analyst or a non-technical person, so say perhaps even someone not familiar with NLP, to be able to reproduce this work, to be able to understand what's going in this workflow compared to the one that we saw before. The other thing is that a lot of these operations that we see in the previous workflow, we can say run a partial amount of it through a step run operation. So what I mean by that specifically is that maybe we can just go halfway through here and we can go ahead and just run everything up to the text featurizer with a step run and see what the intermediate results is. But that's not something that we can easily replicate in the workflow that we saw before. So that's a distinction at least between a high code and low code environment.
Great, Shweta. So I had a question. So what about folks who program on R? Is there a way we could embed R code as well?
Yeah, exactly. So just like we have these Python nodes over here, we also have what we call an R execute node. And that's something likewise you can also develop your own code in and just hook it up to any of the other nodes as you wish.
Yeah, I think this is so powerful because at this point we're seeing the power of three worlds. So we have the inbuilt operators, you also have Python, and you also have analysis that's done in R. So this is super helpful.
Yeah, I think also on top of that, the thing that I do like that you don't necessarily get with code, I mean, maybe in a Jupyter notebook, but less so in a code base, right, that you're preparing, is the actual visualization of how the data is processing through the steps, right? So if you, I don't know, maybe if you can show us an example of that, Sweta, so just run the workflow. You might need to delete the R execute though. So when you're running the workflow, you'll actually see the data being processed, right? It will start flashing and show you at what stage it is. And I think this is actually really helpful trying to understand the steps in your process, because sometimes you might have like different functions and functions and functions, and it's not as easy to pull that apart to say, okay, actually this is what's happening here and this is what's happening there. And so I think this is the actual graphical representation of the workflow, to me, is very, very helpful in helping me understand quickly what you're trying to do, right?
Yeah.
Do you both, I mean, we're both expert coders. Do you both, is there a reason beyond the things we've discussed that you might think of that might be why someone who's an expert coder would be interested in using these tools?
Yeah, I think as I think there are two ways to look at this, right? I think one is obviously if you're really looking to, before you start getting into the nitty-gritty of things and really coding things out, you might just want to get a very high level overview of how or what your data looks like. And I think the inbuilt or the low code operations within TIBCO Data Science really offers you that. So you don't necessarily have to spend hours and hours trying to code that out, but you can actually leverage these inbuilt operators to quickly tell you or just give you an idea of uh, if you're approaching the use case in the correct way, or how does the data even look like? Do we need to make any changes before that? But for a data scientist, or even for analysts and engineers who are who love writing code, this is also a great a great area for them to to incorporate their work and get uh, you know um, get the power of both the worlds. If they're looking for a very custom algorithm, or if they're looking for a very custom analysis that they cannot find within the list of operators, they can always write their own custom logic and incorporate that within the workflow. I think this workflow is also a great way to explain your analysis to business stakeholders within the organization. I would at least think, in my experience, it's far better than just walking business stakeholders over cells and blocks of code, which is not very pretty. So I think this is very, very super helpful for all the user personas involved.
Yeah, I would have to agree. And reiterating on some of those points, I think I can break it into at least three categories on the top of my head. It's more efficient. So, saving your time. You can drag and drop any one of these operators as opposed to write, let's say, a minimum of 10 lines to 20 lines of code. Um, and on the second hand, it's also better reproducible. So you can see the intermediate results of some of your work, and a colleague without the same technical skill can be able to replicate that. And lastly, it's for the explainability or the interpretation. So if you ever need to explain exactly what went into your analysis, um, you can actually visually see it here. So I wouldn't even need someone to tell me what's really going on here. I could be able to, kind of pick it up myself just based on the DAG again, or based on how this workflow looks.
Exactly, exactly. Well, thank you both for walking us through that example and showing us the reasoning right behind using no and low code, and as expert data scientists, why it actually might be useful to you. So thank you for giving up your time to talk to me today.
Hey, no problem, Nora.
Thank you.
It was a joy.